Okay, this is the problem. Evaluate the solution. Single 0.10 meters times 0.10 meters square. Loop is between the poles of the large electromagnetic surface of the loop makes 53 degrees angle with respect to the magnetic field. That is this thing is constant, that it does not change. The magnetic field varies as shown in the illustration. So magnetic field varies. Okay, determine the induced electromagnetic force produced by the loop. Electromotor force. Proposed solution, sketch the translate. See the drawings on the right. So this was the proposed solution, and this printed thing is what is proposed. And this is what I did. So, solution is when you have, you need to have sign minus, because induced electromotor force is always, how do you say that, opposes the change in flux and whatnot. And this n is number of terms. So you have here only one term. But if you have coil, you will have as much term as the coil has terms. So there is only one, let's say, term here, and that is n is 1. B, and this delta, B a cosine of theta. So this is the flux, change of flux in change of time. This is magnetic field, or magnetic induction. This is the surface area. A cosine of theta is cosine of this angle here. And a cosine of 53. Okay. Cosine does not change, so that this angle does not change over the time. It could sometimes, but in this specific case it does not. Area is always also does not change, but this, as you can see from this graph here, it does change. So magnetic field changes from 1 Tesla to 3 Tesla in the time of 1 second to 3 seconds. So as you can see here, the final magnetic field was 0.6 Teslas, and that was for in the 3rd second. But magnetic field was 0 Teslas when the time was 1 second. So in the span of 2 seconds, field change from 0 to 0.6 Teslas. And that's all there is to it. There's nothing more here. And that is minus 1.8 times 10 to the minus 3 volts. And this is induced electromagnetic force. There is absolutely nothing more in the PDF file, but if you want, you can donate. For complete written answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. So this solution here that is given was very close, but problem was first there was no minus sign here, and as you can see 0.6 to minus that to 0, that is good, but 3 seconds to 0 seconds, this was 0, so from here to here that is not correct, because this change of field is much shorter, as you can see, and because of that this induced electromotor force is larger than the one they calculate. Okay, and as you can see here, it's usually here somewhere 0. So this is a flux, and this is an induced voltage or electromotor force. As you can see, that is negative value. So that is correct. So as I said, there is nothing more in PDF file, but if you want to donate, you can. So see you. Thank you.